Tree. Good day, everyone. I am Margarita T. Marquita III, and I am so excited to welcome you all to another fun and interactive mathematics session. Today, we are going to dive into the world of 3D geometry. But before we begin, let's look at these 3D objects. What do Rubik's Cube, a standard playing die, and this box have in common? Yes, they are all cubes, but have you ever wondered how much space is actually that box? Or how many tiny blocks make up this entire Rubik's Cube? Today we are going to learn exactly how to measure that space. By the end of this video lesson, you will master the concept of volume and confidently calculate the volume of any cube using a simple, powerful formula. Before we talk about volume, let's look backward for a moment. Previously, we learned about area. When we find the area of a flat shape like a square, we look at two dimensions, length and width. We measure it in square units, like centimeters squared. But look at this cube on the right side of your screen. This one. It's not flat. It stands out. It takes up space. This is a three-dimensional shape. It has length, width, and height. Because it occupies space in three dimensions, we don't look for area. We look for volume. Volume is the amount of three-dimensional space of an object occupies. Now, instead of just looking at flat drawings on a slide, let's bring mathematics to life. I am switching my screen over the GeoGebra 3D Calculator, a powerful, interactive software that lets us look at shapes in real three-dimensional space. Look at my screen right now. You can see three colored lines crossing each other. So here you can see blue line, red line, and green line. In 2D, we only have the red line, this one. That represents the x-axis for the length, and the green line that represents the y-axis for the width, this one, the green line. But because we are dealing with 3D space and volume, GeoGebra gives us this blue vertical line, this one, blue. This blue line represents the z-axis, which is our height. So this is our height. Watch as I left click and rotate the screen. Watch and observe. Notice how we can view this object from the top, from the side, and from the other underneath. This is exactly how a real object occupies space in our physical world. Now, let's look closely at the base of this cube, sitting on the gray grid. So this one, here. This is the base. So let's count the grid units along the red length axis. So here is the red line or the red axis. So let's count 1, 2, and 3. Now let's look at the green width axis. Green width. So this is the green width right here. So let's count from 0. 1, 2, 3. So there are also 3 units. If we apply just the floor dimension, like we are finding the area, 3 times 3 gives us 9 square units on the bottom floor. Now look at how tall this cube grows along our blue height axis. So this is the blue axis. Let's trace it upward together. 1, 2, 3. 3 units high. Because GeoGebra builds this perfectly, we can see that it takes 3 layers of those 9 base squares to fill this entire container. So mathematically, we calculate 9 times 3, or length times width times height, or 3 times 3 times 3 is equals to 27. GeoGebra confirms that the total space is exactly 27 cubic units. So now, what? Watch what happens if I adjust our side values. So we will adjust it from 3 to 4. So to adjust it, you just click right here, then change the number 3 to, for example, number 4. Now, as you can see, it's also changed. Let's zoom out. As the sides expand from 3 units to 4 units, the entire shape scales uniformly in all 3 directions simultaneously. This perfectly proves why our formula is V is equals to S to the power of 3, or S cubed. Because it is a cube, you can never change the length without the width and, and height changing by the exact same amount. Every single edge is perfectly identical. And also, every face of the cube is also identical. Now that we have visualized how a cube fills up 3D space using GeoGebra, let's switch over to our virtual whiteboard and practice calculating these volumes by hand so you can ace your upcoming exams. Important reminder in answering volume problems. Always remember that your final answer must be written in cubic units. For example, cubic centimeters, cubic meters, cubic inches, or centimeter to the power of 3, meters to the power of 3, inches to the power of 3. If you forget the small exponent 3, your units won't represent 3D space. So now, let's work through an example together on our virtual whiteboard. So here, I am using Microsoft Whiteboard. And as you can see a problem stating that suppose we have a cube and, and the measurement of one of its sides is given as 5 centimeters. Because it is a cube, we automatically know all its edges are 5 centimeters. So first, or the process to solve this problem is, let's write down our step-by-step process. So step 1, you can type your answer or write in this whiteboard. So we just write in this step. So step 1, state the formula. So again, the formula is V is equals to S times S times S. So I hope you can understand now. So the next step is to substitute the known values. So our known values here is 5 centimeters. So now, since it is hard to write, I just type the step 2. So V is equals to 5 centimeters times 5 centimeters times 5 centimeters. So this is the step 2. So we will write here step 2. Step 2. Step 2. So this is step 1. It's kinda hard. So for the step 3 is to calculate the product. So let's calculate step by step, or let's do it in pieces. So first is, so we will write here step 3. Step 3. So first we will solve for this for first two parts. So 5 times 5. So we will change the color to blue. So 5 times 5. 5 times 5 is equals to 5 times 5. 25. Right? Am I correct? So 25. Now what is 25? 25 times 5. So 25 times 5. Yes, excellent. Is equals to which? 25 times 25, 125. Correct. No, sorry for that. There is 125. So now, we have now a value of 125. So step 4, change the color. Now step 4, we will write here. Step 4. So step 4 is attach the correct cubic units. So copy the 125. So we will type it here. 125, 25 cubic centimeters. Centimeters. Am I correct? Yes. So now, that is the final answer for this problem. 125 cubic centimeters. And that's all for our mathematics session for today. As an officer of Mathematics Teachers Association of the Philippines, it is my absolute mission to make learning math easier, highly accessible, and engaging for all learners across our country through the power of internet. Keep practicing, stay curious, and I will see you all in our next video lesson. Happy learning, everyone!